When are two polynomials identical? Identical. When are two polynomials identical? That's a question. Say there is one polynomial, call it Px, which is a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus an. This is one polynomial. And say there is another polynomial qx, which is b0 x power n plus b1 x power n minus 1 plus b2 x power n minus 2 plus bn, right? When I say two polynomials are identical, that means px is identically equal to qx. Px is identically equal to qx. What it means is a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus an. This expression is identical to this expression. b0 x power n plus b1 x power n minus 1 plus b2 x power n minus 2 plus bn. What it means is that if you take any value of x and plug into, say, x equal to some alpha, you plug into this, then the value of this expression at x equal to alpha must be the same as the value of this expression at x equal to alpha. If you take x equal to root 2 here and find the value of this expression at x equal to root 2, that must be the value of this expression at x equal to root 2. If you take x equal to 16.7 here, then the value here must be the same as the value here at x equal to 16.7. That means the value of this expression for any value of x, real or complex, must be the same as the value of this expression for the same value of x. That's when we say they are identical. That means, you know, x squared minus 1 is x plus 1 into x minus 1. They are identical polynomials. It's an identity. And plug in any value of x here. What you get on the left hand side, for the same value of x, you get the same value on the right hand side. So these two polynomials are identical. Right? They are identical. And of course, every time you factorize something, you always get an identity. Suppose I say x squared plus 1 equal to 3x squared for example. Are these two polynomials identical? No, they are not identical. They are not equal for all values of x. So they are not identical. This is an equation. This is not an identity. This is an equation. This is true only for some values of x. That means 2x square equal to 1, x equal to plus minus 1 by root 2, they will be equal. But for x equal to 0, is this equal to this? No. That means this is a polynomial of degree 2. This is also a polynomial of degree 2. But they are not identical polynomials. But these are identical polynomials. If I have 3x square plus 4x plus 1 equal to 5x squared plus 2x plus 3. Are these identical polynomials? No, they are not identical polynomials. This is an equation. It's going to be true only for some values of x, not for all values of x. So they are not identical polynomials. This is a polynomial of degree 2. This is a polynomial of degree 2. But they are not identical. Right? They are not identical. This is an equation and not an identity. But if I said 5x squared plus 2x plus 7 equal to 5x squared plus 2x plus 7. For all values of x, this expression assumes the same value as this expression. These two polynomials are identical. That means the only condition that will cause two polynomials to be identical, let's say two quadratics to be identical, is if the coefficient of x square in this polynomial is equal to coefficient of x square in this polynomial. Coefficient of x here must be the same as coefficient of x here. The constant term here must be equal to constant term there. Yes or no? That means two polynomials, write down, two polynomials would be considered identical. Two polynomials would be considered identical if and only if coefficients of equal powers of x, if and only if coefficients of equal powers of x be equal in both polynomials. So, if will these two polynomials be identical? No. It's an equation. Now, also write down, every time one factorizes a polynomial, then the unfactored and the factored polynomials produced are identical polynomials. See, this is a polynomial, this is the unfactored and this is the factored. This is the factored and this is the unfactored. Whenever you factorize, so there is an unfactored polynomial, there is a factored polynomial. And this is like x squared minus 1. This is like x squared minus 1 when you multiply. And do you see that these two polynomials are identical? The factored and the unfactored polynomials will be identical. Coefficient of x power London in one polynomial must be the same as coefficient of x power London in the other polynomial. That is important. That's when they will be equal for all values of x. Yes or no? Now, these two polynomials would be identical. So factorization will always produce identical polynomials, right? Now, if these two polynomials are identical, then coefficient of x power n here, which is a0, must be equal to coefficient of x power n here, which is b0. Coefficient of x power n minus 1 here, a1, must be equal to coefficient of x power n minus 1 here, which is b1. Coefficient of x power n minus 2 here, which is a2, must be equal to coefficient of x power n minus 2 here, which is b2. Coefficient of x power 0, this is coefficient of x power 0, an must be equal to bn. An must be equal to bn. Huh? There is no ratio involved here. They have to be equal. Ratio obviously is 1 here in all these cases, a0 by b0, a1 by b1. So, two polynomials would be identical. That means we'll assume same values for all values of x. Not all two polynomials would be identical, but if they are identical, they assume the same value for all values of x. That will happen only if their respective coefficients of equal powers of x are equal. That's when two polynomials would be identical. Now, if px is identically equal to qx, then px minus qx will be identically equal to 0. That means will be 0 for all values of x. Px minus qx will be 0, not for some values of x, but will be 0 for all values of x. That is what it is meant by identically equal to 0. You know what I'm saying? But px minus qx is a0 minus b0 x power n plus a1 minus b1 x power n minus 1 plus a2 minus b2, right? Px minus qx, a0 minus b0 x power n, a1 minus b1 x power n minus 1, a2 minus b2 x power n minus 2, an minus bn, then will be identically equal to 0. That means it will be 0 for all values of x. This is a polynomial. And if it becomes 0 for all values of x, the only possibility is that this must be 0. That means a0 must be equal to b0. That means this must be 0. That means a1 must be equal to b1. This must be 0. That means a2 must be equal to b2. This must be 0. That means an must be equal to bn. That means if a polynomial, this is a polynomial of degree n, and if it becomes 0 for all values of x, not for some values of x, but for all values of x indiscriminately, then the only possibility is coefficients of all powers of x must be 0. Right? That means a0 must be equal to b0, a1 must be equal to b1, a2 must be equal to bn, b2 and so on. That means two polynomials would be identical if their difference is 0 for all values of the variable, say x. And that can happen only if the coefficients are equal. a0 must be equal to b0, a1 must be equal to b1. If even one of them are not equal, then px will not be equal to qx for all values of x. It will be equal to qx only for some values of x. Then it will not be identically equal to qx. Then px equal to qx will not be an identity, it will be an equation. Yes or no? And if somebody says that there is a polynomial, say a1 x power n, a0 x power n plus b0 x power n plus, say a1 x power n minus 1 plus a2 x power n minus 2. If somebody says that this polynomial, this is a polynomial of degree n, how many roots would you expect out of this? N roots, not more than n roots. But if somebody says that it is becoming 0 for all values of x, that means it has more than n roots. This is a polynomial of degree n, right? And if somebody says this polynomial a0 x power n, a1 x power n minus 1, a2 x power n minus 2 plus an is becoming 0 for all values of x, then you can say, hey, a polynomial of degree n cannot have more than n roots. But the moment it has more than n roots, now it has more than n roots. If somebody is saying that it is becoming 0 for all values of x, means it has more than n roots. That can happen only if a0, a1, a2, an are all 0. If this is identically equal to 0, if a polynomial becomes 0 for all values of x, then all the coefficients must be 0. That means a0 must be equal to a1, must be equal to a2, must be equal to an. Each must be 0. Each must be 0. So 1, when are two polynomials identical? When the coefficients of equal powers of x are equal. 2, if a polynomial of degree n vanishes for all values of x, then all the coefficients have to be 0, equal to 0. Equal to 0. Yes or no? Do you all understand this? What does factorization give you? It gives you a factored and an unfactored part. Both the factored and the unfactored polynomials are identical polynomials. What does factorization do? It gives you identical polynomials. One which is in a factored form, one which is in an unfactored form. It's valid for all values of x. That's why it's an identity. That's when the two polynomials are identical. Right? And for two polynomials to be identical, I repeat, what is required? For them to be identical, for them not to be an equation. If coefficients of equal powers of x be equal. When is a polynomial identically equal to 0? That means 0 for all values of x. That can happen only if the involved coefficients are each equal to 0. Yes or no? Stand by.